Okay, I'm here to help you out with problem number 94 from homework 12 on page 455. This is the problem dealing with finding the area of an ellipse. As you can see, I've drawn the picture that they have in the book here, which is the ellipse. Right here is the equation for the ellipse. So we get working with our slices. We take a generic slice sort of here at this x value x, and I draw my picture. We know that this point here has a coordinate x comma y. So all we have to figure out is what is the height of this rectangle. And if you see, this top half has height y and the bottom half has height y. So the height is 2y. So the area of the slice is 2y, and then the width, it's a little change in x, so we call that dx. So what we need to do now is integrate over all possible slices, and we know that means to integrate from minus a to a, because that's where I can take all my x slices, and the formula in the integral is the area of a single slice. So all this requires now is for me to figure out what y is. Well, I have to use this formula here to decide what y is. Using a little bit of algebra, I can solve this formula to say y squared is b squared times 1 minus x squared over a squared. You should think about that. And now y is a positive number, so I can take square root b squared 1 minus x squared over a squared. Again, doing a little bit of manipulation, the b can come outside the square root, and I get 1 minus x squared over a squared. And finally, getting a common denominator, I can get a squared minus x squared over a squared. All of that's under the square root. And I can use that to solve y is b over a, square root of a squared minus x squared. So finally, putting that back into this equation, I get minus a to a, 2b over a, square root of a squared minus x squared dx. All of these things are constant, so they can pull on the outside of the integral, and I'm left with this integral here. And here's where the trickiest part of the problem comes from. This integral right here is something you should know. This is the area of a semicircle with radius a. So hopefully that helps you solve the problem.